our universe is constantly expanding, making it difficult to establish its limits and measure its size. However, thanks to the James Webb Space Telescope, we can now glimpse into the farthest corners of the universe. Since the James Webb Telescope began its exploration, numerous scientists, such as Brian Cox, have made announcements revealing the true size and vastness of the universe, which is almost unimaginable. Within the fragment of the universe that we can observe, there are approximately 2 trillion galaxies. This estimate is based on studies of the local universe, but we are quite sure that this portion we can see is only a small part of what could be an infinite universe that we do not yet fully understand. We are not separate from the universe, rather, we are an integral part of it. In a way, the universe knows itself through us. With the help of the James Webb Space Telescope, we plunge into a vast exploration to discover the true size of our universe. If you're interested in keeping up to date with news about the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. If we were to travel at a speed of 70 miles per hour, it would take us about 15 days to complete one lap around the Earth's equator. It would take approximately 5 months to reach the Moon, 63 years to reach Mars at its closest point, and a staggering 4,400 years to reach Neptune. These figures alone demonstrate the immense scale of our solar system. To put this in context, consider Voyager 1, launched in 1977 at a speed of 38,000 miles per hour. It did not leave the solar system until 2012. This means it spent 35 years just to get out of the solar system. Even light, which can circle the Earth 7 times in a single second, seems relatively slow compared to the vastness of our solar system. And although our solar system is vast, it is dwarfed by the enormity of the Milky Way galaxy. This galaxy contains approximately 300 billion stars, each of which probably has its own planetary system. Our nearest neighboring star, Alpha Centauri, is 4.3 light-years away, which means that if we were to travel at the speed of light, it would take us 4.3 years to get there. Now imagine how long it would take us to travel to the next star system. Even if something were traveling at the same speed as Voyager 1, that is, 38,000 miles per hour, it would take a staggering 77,000 years to reach Alpha Centauri. This illustrates the immensity of the distances involved in exploring the cosmos. Now, let's focus on Beetlejuice, a star located 640 light-years away. If we consider what we call the radiosphere, this represents the distance our radio transmissions have covered in the last century. Although the signals have degraded significantly, they have so far reached about 15,000 star systems. However, this figure is only a fraction compared to the number of stars in the Milky Way. If you look at Beetlejuice in the night sky tonight, you are actually seeing the light that left its surface 640 years ago, about 100 years before Columbus set sail for the New World. This light has traveled for all that time and is just now reaching our planet. It is truly amazing to realize that Beetlejuice on a universal scale is relatively close. To surprise you even more, we must consider that our radiosphere, which encompasses all human radio transmissions, is only a small dot within the immense expanse of the Milky Way. Let us help you imagine this. If we were to reduce our solar system to the size of a quarter, then, by comparison, the entire Milky Way would be the size of the United States. In this immense region, there are about 300 billion star systems and planets. We are just one of those 300 billion star systems, floating in the midst of an unimaginably large number of stars and planets. Beyond our galaxy, there are at least 1 trillion more galaxies. Yes, 1 trillion. 1 trillion is an incredibly large number. To understand its magnitude, imagine a collection of 1,000 cats. Now suppose there are 1,000 groups of cats, each consisting of 1,000 cats. That would give us a total of 1 million cats. But to understand 1 trillion, we must remember that there is already 1 million represented in that number. So, a trillion equals a million times a million, which is a staggering number of cats. Our nearest neighboring galaxy is the Andromeda Galaxy, located 2.5 million light-years away. Andromeda is rapidly approaching us at a tremendous speed. As this galaxy gets closer, our night sky will undergo significant changes. This galaxy contains about 1 trillion stars, and when it eventually collides with our Milky Way galaxy, which has 300 billion stars, the chances of individual stars from both galaxies colliding are quite slim. This illustrates the vastness of space and the low probability of direct interaction between stars within a galaxy. Galactic collisions, although rare on the level of individual stars, may even facilitate life between stars and galaxies. Galaxies are not static systems but are dynamic and constantly evolving. As we move away from our galaxy, we find our local group of galaxies, followed by the Virgo cluster, which contains more than 1,500 galaxies. The Virgo cluster is part of a larger supercluster known as Laniakea, which contains approximately 100,000 galaxies. Each of these 100,000 galaxies has hundreds of billions of stars and planets. And this is only a small part of the picture. In the observable universe, there are another 10 million superclusters similar to Laniakea. Beyond the galaxies, we find regions in space known as cosmic voids, where matter is scarce compared to the rest of the universe. These cosmic voids are immense, spanning hundreds of millions of light-years in diameter, appearing as vast expanses of seemingly empty space. However, these cosmic voids have the potential to give rise to the formation of future structures and galaxies. We also find cosmic filaments, colossal threads composed of dust, gas, and dark matter that stretch across billions of light-years, connecting galaxies and galaxy clusters. The scale of the universe becomes even more staggering when we consider the vastness beyond mapped galaxies. There are a staggering number of galaxies that have not yet been fully mapped or observed. Furthermore, due to the continuous expansion of space, the light from most distant galaxies will never reach us. As a result, these regions may remain inaccessible to us indefinitely. As the universe expands, we can make inferences based on our understanding of the laws of physics. These suggest that the entire universe is at least 250 times larger than the observable universe. Some theories even suggest that its size could be infinite. Contemplating these possibilities invites us to reflect on our existence and our role in the cosmos. Have you ever wondered how vast our universe is? If so, I hope this has helped you understand even a little bit more about the vastness of the cosmos. If you have any questions, use the comment box to share them. If you like the video, hit the like button, share it to reach more people, and subscribe so you don't miss more content like this. Thank you for watching, and I'll see you in the next one.